For this video, we are going to find the volume of different kinds of pyramids. To find the volume of pyramids, we're going to follow the same 3 steps we've been following for all of our problems that have formulas. We're going to start by writing the formula. Now, when you are dealing with a pyramid, the formula is slightly different. It reads the volume is equal to 1/3 times the area of the base times the height of the pyramid. Basically, all of our figures that come to a point, pyramids and cones, you do 1/3 before the area of the base. The second step, as always, is to plug in. We don't know the volume, so I'll write volume equals. The 1/3 is still 1/3, and the area of the base, you have to look at what the base is. This base is supposed to be a square. Because of the computer, it does not come out looking exactly like a square, but it is supposed to be a square pyramid. I'm going to do length times width, because when you're doing rectangular prisms, it's not always a square. Once we have the formula, we plug in. The volume is equal to 1/3. The length of the base is 6 feet. The width of the base is 6 feet. The height of the pyramid is 2 feet. So once we have plugged in, we solve. Now in this problem, the left side is just volume equals, and the right side is just an expression that can be simplified. And it is all multiplication, which means we can just multiply. 1/3 times 6 is 2. 2 times 6 is 12, and then that 12 times 2 is 24. So the volume is equal to 24. And then we have feet times feet times feet. There are 3 of them, so the answer is feet cubed. For problem number 2, we have a triangular pyramid. When finding a volume of a triangular pyramid, it's done the same way as all pyramids and all figures that have formulas. First, we write the formula. Volume is equal to 1/3 times the area of the base times the height. Now, because this is a general formula and I want the more specific formula, I'm going to adjust. Volume is equal to 1/3, but the area of the base in this problem is a triangle. And the way we find the area of a triangle is 1/2 times the base of the triangle times the height of the triangle. The second step is to plug in. Volume equals 1/3. Then these parentheses are going to turn into brackets so that when I plug in, I can still use parentheses. 1/2 is still 1/2. The base of the triangle, now base and height must make a right angle. I have to look at the triangle, and somewhere in this figure, I have to find the right angle of the triangle. And that right angle mark is right here. So the base and height are 4 and 10. It does not matter which one is which, since 4 times 10 or 10 times 4, you're going to get 40 either way. So I plug the base in as 4 feet of the triangle. I plug the height of the triangle in as 10 feet, and then the height of the pyramid would be 6 feet. I close the brackets so that the area of the base is one thing, and then the height of the pyramid is 6 feet. Lastly, we solve. Volume is equal to 1/3. We do parentheses first. So inside these brackets or parentheses, we have 1/2 times 4 is 2, then 2 times 10 is 20. So that is 20 feet, well, feet times feet, 20 feet squared. And then the copy everything we did not use. We did not use the 6 feet. We are still solving, and now it is all multiplication. When it's all multiplication, we can just multiply. And also, we can multiply in any order we want. I don't have to do 1/3 times 20. I don't want to have to deal with a fraction or a mixed number if I don't have to. I can do 1/3 times 6. 1/3 of 6 is 2, and then 2 times 20 gives us a volume of 40. Feet squared was from feet times feet, and now we're times feet again. So the final answer is 40 feet cubed. So to find the volume of a pyramid, you write the formula, you plug into the formula, and then you solve. Just remember that the formula for all pyramids will have a 1/3 in front, since all pyramids are 1/3 the volume of a prism that looked with the same dimensions.